Yes. All right. So we're going to use this as our reference charge. And I'm going to take you through how you would find the net electric force, field, potential energy, and voltage at that particular charge. No, voltage, capital V. So let's draw just that 5 microcoulomb charge by itself. Which way will it be pushed or pulled on the -3 charge? To the left is correct. It'll be attracted. And which way will it be pushed or pulled by this corner? Down and to the right. Good. So to find the net force, we need to resolve this into horizontal and vertical vectors. But let's first put the variables in. So the Coulomb's law, the electrical force equation, is K times Q1. And I can ignore the positives and negatives once I have the vectors pointing in the right direction. Okay? Mu micro is, look up at the board. No, this is +9. This one? K. That's K. Oh. It's +9. Yeah, all right. Come on. And then how far apart are they? 0.03. Thank you. And then this one, we'll do the same thing. Micro, that symbol is -6. It's on the board too, so I'll leave it up there, but no worries. And what's the distance between them? The 4 and the 5? Yep, square root of 13 is correct. Whatever. It's about 3.6. Oh, new color. Yeah. So really, I hate that. Wouldn't be a bad idea for you to plug and chug and see if we get the same thing here. Good practice. And this is where I see, this is why I hate this test, because you can make a very small calculator error, and then I end up having to recalculate everything. A lot of keystrokes. Herschel and I will become very close. Even closer if that's possible. Hey, bite your tongue. Hey, Karen, shoot that what'd you do? You know, I was hungry. This is actually a pretty big force. Oh, you're what? My suggestion would be that you go, if you have time when you're taking this test, that you go back and recheck these, especially these first couple with the vector problems, because it can have then fallout for all the rest of your steps. Okay? And also, if there's ever a test where you should show your work, it's this one. Okay. Anybody corroborate those two numbers? Yes? Oh. I haven't been. All right, now what we're going to do is work on the direction, which means that we really want to try to get everything in horizontal and vertical orientation. So this vector is already horizontal. This one's good to go. It's the hypotenuse value that needs to be broken up into its components. So that and that. So we have to figure out what the angles are in this right triangle, and they are related to this right triangle. Now, so they're similar triangles. If I use the tangent function, opposite over adjacent, I can figure out what that angle is, and then this will also be theta, right? Because there'll be, if I were to pull this up and draw it right here, those would be vertical angles, right? Geometry student from 8th grade? That's one of the things I love about NHS tutoring is a lot of times the kids who need help with math are doing math that my tutors haven't done since middle school. So.
Yeah. At math it was always so shocking when someone comes in there and I'm like, what?
Wow.
Find the area of the triangle again?
Trevor, I forgot. I'm looking for it. That was a joke. No, John,
so the angle's about 33.7 degrees.
Josh, the sad thing is you had to clarify that it was a joke.
Josh, we knew it was a joke.
Well, it's debatable.
I don't know. There's some like kids from upstate out there who are really, really smart whose parents just want them to get ahead in math.
Oh, what? Good for them.
You see what I'm doing here? Trying to get the vertical and horizontal components.
Use the same line twice. Oh, wait, use different ones. No.
And I'm keeping an extra sig fig around here. Actually, I said 2 sig figs, but I'm going to keep an extra one until the last step. Okay. Anybody come up with the same numbers I did? So now we have everything in vertical and horizontal terms. This is a horizontal vector, and this is a horizontal vector. This is our only vertical vector. Okay? So these two horizontals pull to the left and to the right. So what would you do to find the final horizontal? Subtract them. Which way will win? To the left. Good. So to the left I have 150 minus 116 newtons. This is 34. Is that right? Maybe better. I think that's right.
That's right.
Thank you. And then vertically, 77. Just kind of want to draw these so that they're approximately proportionally correct. And that means the final resultant is like this. And how would you find that? Pi fag, right? This one will be the square root of 34 squared plus 77 squared. And it is also typical to give a direction at this point, and it's usually the direction from the horizontal. So since I already used theta, I'll call this beta. And Matt Borey, what's your favorite trig function? Alrighty. So the cosine of beta will equal adjacent over hypotenuse. 66 degrees. And that was just the first step in this list. Find force, electric field, potential energy, and voltage. Yeah. And this is an easy one because I gave you a nice right triangle. I'm glad some of you are smiling. Are you smiling? Are you because you're like, hey, yeah. Yeah, I don't know. Mistake. Okay. I'll give you a sec to catch up. Yes, we do.
Wow, that's great.
Yeah. I hope by now you figured out that the testing process is really part of the learning process in this class. And that's where you have to manage and decide, you know, I mean, some kids go in cold and take the A test, just like the first ACT, right? You just go in, kind of just dipping your toe in the water, trying to figure out what's on the test, how do I approach it, how much time do I need. Other kids are like, I want to front load this, I'm going to study really hard, pass the A test, and then I have the rest of my week to myself. So it really depends on how you like to manage your time. Yes, dear. Yes, you may. And that's a lesson for high stakes tests too. That if you do better when you're more relaxed. Yeah.
Because I took the ACT for the first time, and it's like I hadn't taken it before. I didn't know what to expect. I hadn't even taken a full practice one. I just
Take
took a
some
lot
time.
of practice courses, and especially with reading, because my reading score was really low, and I'm a draw.
How'd you do with the timing?
I had time left in everything except math, because I think I bubbled with a random answer in math.
Okay. That's pretty good, actually. Reading is, I think, hard. I'm not a fast reader, though, so I mean, personally struggle with finishing that.
But I was, for some reason, was under the impression that there were 5 reading passages, and so when I had 10 minutes left in reading, I'm like, crap, I have 2 more passages, and I flip the page, and it's like, do not go on. I'm like,
Oh.
I won't go on.
That's a nice surprise. All right. So this is finding the force. Now, in this particular problem, and most likely on the test as well, you're going to have the same reference charge. Otherwise, you get to redo this again for, you know, each of these other ones. So for electric field, if you look at the board, there are 2 ways to solve for electric field. You can take the electric force and divide by the test charge, or you can do K big Q over R squared. Now, if you do KQ over R squared, you have to do all this vector stuff because electric field is a vector. Electric fields point in a certain direction. So, yeah, let's use the first one. So if we're going to use net force, the answer for force divided by test charge, my question to you is, which one of these is the test charge?
5.
Yeah, which is kind of really not correct. I really should probably put, now I'll go up there and change it, test/reference charge. The reason that this would not be a good test charge is it's big by comparison, right? So, but it can be either the test charge or the reference charge. So yes, if this is the reference charge, then that's what we're going to divide by. So electric field will be net force divided by reference charge, or 84 divided by 5 times 10 to the negative 6. Coulombs. Coulombs. And by the way, I don't know that I actually have talked about this yet, but the units for electric field are? Nope. Nope. Newtons per coulomb. There's no abbreviated unit, just newtons per coulomb, just like it's written. So that's going to be a really big number. 1.6, I'll round it to 1.7, 268, so 1.7 times 10 to the 1, 2, 3, 4, 5, 6, 7. Who said that? Okay. All right. That's 2 down. So So now you've never really seen how to solve for potential energy and voltage. So I'm going to draw this again. And you'll need probably a full, if not more than one full piece of paper to solve these problems. So I'm going to draw this again. Bless you. Capital C. All right. And the distances are 2, 3, and I didn't, oh, and 3, okay. So 2 centimeters, 3 centimeters, and 3.6 centimeters. Okay. So whenever you're solving for scalars, like electric potential energy, this is how it's done. And I'm going to use Q1 as my reference charge. So pretend like this is Q1, this is the reference charge. Oh, my bad. That was on to force. Thank you. Nice job. Extra credit points.
Go Bears.
That's for you, Matt, whenever you get a chance. Dot, dot, dot.
That thing's so long.
Okay. So potential energy is just the sum of the potential energy between the reference charge and all of the other charges that are creating an electric field. So notice there's no, this is it. This is it. There's no other angles, there's no vectors. So it's kind of like the sheet problems in that you're going to add and subtract, but here you do need to include the charge character because positive and negative charges will have an opposite effect. So if your test charge is positive and you throw it in an electric field that has a negative source, what will happen? Will it be attracted or repulsed? Yeah, it's attracted. If I take that positive test charge and throw it into a field wherein the charge source is positive, what will happen to it? It'll be repelled, yes. So those have a canceling effect. So that's why, so for vectors, the only thing that you really need to remember besides plugging and chugging correctly is make sure you include the positives and negatives. For vectors, I did not include the positives and negatives in the math because the positive and negative told us which way the vectors pointed, okay? All right, so let's solve this one. If my reference charge is the 5, then that's going to be Q1 in all of these. And the other value that gets repeated is K. Now, R can change, so here's a shortcut. It'll save you some keystrokes, and that would be to factor out the K. I don't know, this is just a general equation thing, both, so it can go for as many charges as you have. So in this particular case, you're only going to have 2 of them, right? Because you're comparing the 5 to the 4 and the 5 to the 3. So let's actually put our numbers in. K is 9 times 10 to the 9. Q1 is, thank you, 5 times 10 to the negative 6. And then we're going to multiply that by this charge over this distance and this charge over this distance. So let's start with the upper right-hand corner. Positive 4 times 10 to the negative 6 divided by 0.036 plus negative 3 times 10 to the negative 6 divided by 0.03. And you'll probably be able to skip one of these steps. You should, by the time you practice a few of these, be able to jump right to writing this out. So it'll be a little quicker. That was convenient. Who remembers the unit for energy? Joules. And that still applies here. If you want to go look it up, it has to do with the K value, and you end up with just Newton meters, and it does all cancel. It does all boil down to joules. For extra credit, if you want to show how this gives you joules, you could do that. So like go home tonight and like write it all out. A bunch of stuff will cancel, and you end up with just Newton meters. Yeah. Okay? So that's how we figure potential energy. And then if you look at the board, voltage is either the total potential energy divided by the test or reference charge, or you could do K, Q over R, and it would be K, Q1 over R1, plus K, Q2 over R2, plus K, Q3 over R3, dot, dot, dot. So let me write that down for you. Voltage would be K times the quantity, Q1 over R1, plus Q2 over R2. I'm doing big Q because which Q did we get rid of? Yeah, the little q, the test charge. Dot, dot, dot. Okay? So you can do that, or you could do potential energy divided by test charge. So which one's easier? Use this one, divided by the test charge, which is the reference corner. So that's 5 times 10 to the negative 6. Coulombs. And again, this unit, there's nothing, this does have an abbreviation I'll show you in just a minute, but you can also just write joules per coulomb. And when we type that into Herschel, five. It's either joules per coulomb or volts, which is probably a unit you've heard of, right? Usually assigned to what common everyday object? No, that's watts. It's all right. Batteries. Taser. An everyday appliance for you? For you. All right. All right. Yeah. Are you the recipient or?
Both.
I got you. Do your homework! Dang it! All those years, I could have been tasing my children. Nice. Yeah, getting tased is actually no fun. I have a.
It's really fun to watch.
No, my brother-in-law's a state trooper, and he does a lot of training, and he said that he's seen, and he's been tased a number of times, but oftentimes it's so painful that these tasees, people who've been tased, lose control of their bladder.
Wow.
Yeah.
I would definitely do that.
Yeah, so make sure you go to the bathroom first.
Before you commit.
That's right, before you're doing taser practice.
Wait, why do they decide to take
Why? Or resisting or fleeing?
You shoot it. Well, if you have guns like that. They have phase guns. Can't you also just? No.
They actually have two ways that they can use it. It can be up close, or the leads actually have little wires attached, and you can shoot out the little, and they have little, they're like little Velcro. Yes.
They dig into your skin, but if it becomes a knife, then it's.
Yeah, it's not a big deep wound, but it's the electricity. They put a lot of current through your body.
We're gonna tase you again, they start struggling, then
I prefer to use a floss when I tase myself.
Tase yourself?
I prefer to like shoot it.
Okay. So, this, you can see why there's only one problem on